Hi, I'm Allison with the UC Davis Tahoe Environmental Research Center, and I'm outside because it's snowing, so I want to make sure that I get to submit an observation using the Citizen Science Tahoe app in the Stories of the Snow section. So all I need is this handy dandy little black felt card that's been left to get to atmospheric temperature so that it can capture these snowflakes and so that I can actually get up close and take a picture of it. And you do have to get really up close and personal with this to get a good shot, but you do get some pretty awesome shots. Now I'm going to open up the Citizen Science Tahoe app, go to Stories in the Snow, answer a few questions. It's snowing moderately, it's below freezing, and snow is indeed sticking to the ground. I'm going to upload my picture, and just like that, I'm done. Submitted my observation, and now I'm going to actually hand you over to a scientist over at the Desert Research Institute, and he's going to tell you a little bit more about what these pictures can tell the scientists about atmospheric conditions in the Sierra Nevada.
So yeah, Stories in the Snow, we are based out of the Desert Research Institute, and we are a participating program in the Citizen Science Tahoe smartphone application. So what is Stories in the Snow? That's the first thing that I should really cover here. So we are a citizen science program that motivates and encourages students and community members to take macro photographs of freshly fallen snow for science. And so what happens is our citizen scientists take these pictures and submit them through the Citizen Science Tahoe app. And then on the back end, the Stories in the Snow team, myself included, kind of sort through these pictures and see what are the specific attributes and details of all these different snow crystals. We get to, through the app, geotag and timestamp the locations of these images. So as a storm blows through, we get a great picture of what were the different types of snow crystals and snowflakes that fell. And then we use this to really understand what's happening with our local storm systems.
That sounds super interesting. Can you tell us more about how snowflakes form? About
Sure,
snowflakes?
yeah, absolutely. So there are kind of three main ingredients you need for a snow crystal. The first one is water vapor. And so by water vapor, I mean quite literally just water molecules floating around out in the atmosphere. And so when temperatures get cold enough, those individual water molecules kind of get tired of being in its gaseous form. So it looks to move on into a solid form. And so it does this through a process called a deposition, where you move from a gas to a solid. And in order for this deposition to occur, we need our last ingredient, which is a ice nucleus. Don't let this name scare you in any way. It's actually kind of interesting. So all an ice nucleus does is it provides a great framework for these water molecules to arrange themselves onto it in a hexagonal lattice structure. And so what we really call water in a hexagonal lattice is just, it's ice, right? And so in this case, it's this deposition process in this hexagonal lattice that gives snow its incredibly unique crystalline structure that we all really associate with wintertime.
So what are those different shapes? I know the snow is always different, and what do
Yeah,
those different shapes mean?
yeah. So snow starts off, it just wants to be basic. It wants to take things easy for a bit, and it forms in these really simplistic structures that are typically plates or columns. And then as it travels through the cloud, through the storm system, it can grow into larger, more complex structures, or it can remain fairly simple depending on the environment with the cloud. Now, as snow gets more complex, people want to ask one really big question. Do you know what that question is?
I bet Allison knows.
Allison?
Why are there no two alike?
Oh, nailed it. Yes. Everybody wants to know, is it possible for two snow crystals to be alike? Are there two identical snow crystals out there? Now, I've personally never looked at every single snowflake, but snow develops on a molecular structure. And so as a result of that, it's very finicky in a way. So what's happened is some very smart researchers have tried to grow identical snow crystals in a lab using the most precise instruments possible. even in doing that, they still got snow crystals that were different despite their best attempts to make them identical. And so the circles that you see on this current slide on those snow crystal images kind of highlight those minor differences between what were intended to be two perfectly identical snow crystals.
They're
so
close.
If we can't
They're
do it in a
close,
lab,
but not identical.
That's right, close but not identical. If we can't do it in a lab, I don't know what the odds are of it happening out there in the world. So let's get back into, what can snow crystals tell us? Well, snow crystals, each one has a story. That's why we have stories in the snow, right? So clouds are very heterogeneous in the sense that temperatures and moisture levels from the top of the cloud to the bottom, from the left to the right, it varies a lot. And so when a snow crystal begins to form, it takes a very unique path through that cloud and it encounters unique amounts of temperature and moisture, and that creates lots of different types of snow crystal shapes. So this graph that you're looking at, which is a morphology chart of snow crystals, really kind of helps parse out, where do we typically see the most common types of snow crystals. So with all of this, go ahead.
So it would be really fun to capture these. So I know the thing I like the best about the stories in the snow is getting that lens out and taking a closer look, because we notice that they have different shapes and we notice that there's different types of snow crystals, but really getting the little lens on our phones and checking it out is fun. So
yeah, absolutely. I mean, I love seeing images come in from our citizen scientists. And, I'm just going to quickly highlight a couple that we see that's kind of relevant and important to, our work. But one thing that we look for a lot is kind of this rhyming characteristic. So when you look at these images, you'll kind of see like crystals almost look like they're bedazzled or like bejeweled in a way, right? They got these unique bumps on them. And so that's what we call rime. And rime is just essentially what happens when there's too much moisture in a storm system and it can't all effectively transform into snow crystals. So what you get sometimes are just these water droplets that end up bumping into snow crystals, then they freeze on them. So when we see that, we can—
that's the white
Yes.
that we see on this. And what we're seeing in the background is actually the little black card that you capture the snowflake on.
Yeah.
That's what the furry looking stuff is.
Yeah, exactly. So the furry looking stuff, that's our felt card that comes with the kits and kind of helps keep the snow crystal in place. Also kind of gives you a sort of sense of scale. Those fibers are about the same diameter as like a human hair. So you're looking at something that's pretty tiny here. And so, yeah, when we look at this and we see all these little water droplets that are frozen on there, we can say that part of the storm had a lot of abundant moisture in it.
So this can really tell you a lot. So how can people get involved if they wanted to join and contribute observations?
Yeah. So we love to get as many observations as possible. The more information, the better. So on the slide, you'll just kind of see a picture of our webpage on the DRI website. So go ahead and follow that URL down below. If you are interested in getting involved, just move over to that Get Started tab right there on the screen. And please join us in some fun snow crystal science this winter and future winters.
All right. Thank you for telling us about stories in the snow, Eric. Have a great
day.
Yeah,
thank you so much for having me.
Thanks so much, Eric, for all the information. Now we have some real context for what our citizen science observations are doing. And now I'm going to go live with Mark, who's in Tahoe City, and he's going to actually collect some citizen science data for us.
Once you get some good snowflake pictures, then you can open up your citizen science app for stories in the snow and post those along with just a couple of questions about the information about where and when you collected the snowflakes. So that's all there is to it. The hardest part is getting out in the blizzard, but that's really a fun part. You really need to get out. You shouldn't just sit around home all day waiting for the snow to go away. You really need to get out in the snow and collect snowflakes. We got a lot of good ones here. It's been snowing all night, and we'll have some good pictures to post. Thanks very much for joining us for our stories in the snow.